Right, COT theta, but how do we read this? Cotangent theta. Okay? Based on these names, is there something that we can tell, something that gives us a clue about this and our existing three Trigo ratios? 1 over? I guess some of you have read in advance. I think the easiest one to understand will be cotangent theta. Obviously, it's got to do with which Trigo ratio? No. Cotangent. Obviously, it's got to do with tangent theta. Okay? So now, this is how we are going to rewrite this. Okay? Cotangent theta is simply, and listen carefully to the word I'm saying, reciprocal. Heard of it before? What does reciprocal mean? Huh? Back and forth? Okay, go. Reciprocal, okay, side reciprocal of x is 1 over x. Okay, reciprocal. Please do not write x equals to 1 over x. Okay? No. We are saying that reciprocal of x is 1 over x. Okay, next one. Reciprocal of 1 over b is b. Good. Reciprocal of a over b is b over a. Okay, very easy now. Cotangent theta is the reciprocal of tangent theta. Okay, so cotangent theta is 1 over tangent theta. Secant theta is the reciprocal of cosine theta. So we have 1 over cosine theta. Cosecant theta is the reciprocal of sine theta. So we have 1 over sine theta. Okay, that's all. It's just new names that we came up with for these three Trigo ratios. Okay, so you see we already have on the board sine theta, right? Sine theta is y over r. So what do you think cosecant theta is? One more time, all think together with me. We are given that sine theta is 3 over 4, and they are so nice to tell you that theta is acute. So which quadrant does theta lie in? So theta in Q1, first quadrant. When you see this type of question, what must you do next? Sketch, yes, sketch. So it is in the first quadrant, right? So sketch it out. This is theta, and they tell us that sine theta is 3 over 4. Which of the side of the triangle is 3? Opposite is 3. So this must be 3. Where is the 4? Hypotenuse. And what is the adjacent, or rather the x value? It's not unknown, huh? 16 minus 9 is not the answer.
16 minus 9 is
Square root of 16 minus 9, which is square root of 5, right? Oh, 7. Okay, square root of 7, huh? Because this is a right angle triangle. Now they want secant theta. Okay, sounds easy. Secant theta is the same as 1 over which one? Cosine theta. Then what do we have for cosine theta? Based on the triangle, what is cosine theta? Square root 7 over 4. Can we leave our answer like that, fraction in a fraction? No. So what must I do? 4 over root 7. Oh yeah, then I cannot leave insert. Then how? 4 root 7 over 7. Okay, so that's the answer. Is there anything, what have we learned from this example? What is the new concept that we have learned? It's just the reciprocal. Secant theta is simply the reciprocal of cosine theta. Right? Okay. Benedict, help us with the next question. On practice now 18. Yes? Okay, focus. Read the question. It says that cotangent x is 2.5. So from the question, cotangent x equals to 2.5. Straight away, what do you have to do? Are you okay? Are you comfortable with cotangent x? Not really, right? So what would you like to change it to? Okay, so this becomes 1 over tangent x is 2.5. In other words, tangent x is equal to 1 over 2.5. How much is this? 5 over 2, 2 over 5, right? Okay, tangent x is 2 over 5. That's it. The whole question is now reduced to become, hey, tangent x is 2 over 5. Alright, and they say that x is acute. Yes? If it is very straightforward, it's okay not to do your square root, this square minus that square, whatever not lah. Okay, so this is tangent x. And they tell us that this is acute. So which quadrant is x found in? Quadrant 1. Yes. And what should we do next? Now that I know x is in quadrant 1. Draw. Okay, sketch. Over here. Right angle triangle. Our x will start from the positive horizontal axis, go anti-clockwise, and this is x. Where is the 2? Vertical, horizontal, diagonal? Vertical. What about the 5? Horizontal. What about the diagonal? Square root? 29. Okay. So it is just a number, square root 29. And we are supposed to find secant. This is part 3. Secant of pi over 2 minus x. You see this pi over 2? Without degrees. So what mode are we using? Radian. Pi over 2, if you want to convert it to degrees, what will it be? How many degrees is pi over 2 radian? 90 degrees, huh? It is simply 90 degrees. Okay. Now, secant. What is the first thing that we can do? 1 over cosine. Is it just x?
90 degrees.
No 90 degrees. Pi over 2 minus x. Okay, this step, we're just changing only. And I hope that you have already memorized it. Huh? Now, where is this pi over 2 minus x? What is this angle over here? Is this angle inside my triangle? Okay, where?
One person say yes.
Last angle, referring to this one? Is this really pi over 2 minus x? Why will it be so? Huh? What is this pi over 2 minus x? What is this angle over here? In radian, what is it?
Pi over 2.
This is pi over 2, right? What is the angle sum of triangle in radian? How much is it in radian? Pi. 180 degrees pi. So pi minus pi over 2 is pi over 2 again. Pi over 2 minus x, we get the last angle. Okay, so this angle is actually found inside my triangle already. So what is cosine of that angle? What is cosine of that angle? Where's your adjacent? Which side is it? 2. Okay. So 2 over hypotenuse? Square root 29. And we get the answer as? Square root 29 over 2. Done. Okay? Okay, so you can do your homework questions. But I want to... The next topic is on 8.8 Trigo equations. But before we do that, I want to recap on solving algebraic, 1 and 2 algebraic equations using graphs. Okay? First one, if you are told to solve graphically x plus 2 equals to negative x plus 3, what will you do if you have to solve graphically?
Minus 1.
Okay, so Darius says that this is 2x.
Wait,
What?
Put all the x on one side.
Put all the x on one side, but are you solving graphically? Not what you're doing is solving using algebra, right? Put all the x terms on one side, put all the constants on the other side, you solve for x. Mental sums are how much is x over here? X equals to half, because half plus 2 is 2.5. 3 minus half is 2.5 again. So left hand side equal right hand side. Yeah, you're right, X is half. But how do we do it graphically?
Draw to like.
It means must draw graph, right? What is the first graph to draw? Okay, so first we draw y equals to x plus 2. So assuming we have this already. So now we put a bracket over here and we write down this is y. And we write down draw y equals to negative x plus 3. So how many graphs are we drawing over here? 2. The first graph is y equals to x plus 2, sloping up or sloping down? What is the y-intercept? So this is y equals to x plus 2. What is the other graph that I need to draw? Negative x plus 3 is not a graph. It must be y equals to negative x plus 3. What is the y-intercept?
Negative 3.
Why negative 3? It is 3. What is the gradient? So it must slope down. For these two graphs, right, what is the product of their gradient? For these two straight lines? Are you sure it's 1? Product of gradient, what is it? Negative 1. Because 1 times negative 1 is negative 1. What does that tell you about these two lines? They are perpendicular. So it's sketch a perpendicular line. Okay, so over here this is 3 and this is 2. Okay, now I have my two graphs already, y equals to negative x plus 3. And the point of intersection over here, how many solutions are there? One solution. And if we plotted it out, what would this value be? Half. The value will be half if we plotted it. Does the y value matter in this case? No, because the original question is solve this. So I'm only interested in x. The y-axis over there is just a tool to help me plot. Okay, so I'm only interested in the x value, which is half. Now the next one. Solve graphically again. What graphs will you draw over here?
Parabola.
Parabola. What is the parabola you are drawing? Draw. Y equals to x squared, is it? That's it? Minus 9. Okay. You can draw y equals to x squared minus 9. Instead of drawing, I'm going to do a sketch, okay? What shape is this? Parabola opening upwards. So that will be y equals to positive coefficient of x squared. Then there's a minus 9, right? So what do I do with my y equals to x squared? Let's say this is y equals to x squared. So this is my x. This is the y. Okay, y equals to x squared. Done. By 1 minus 9, then what do I need to do? Move the x-axis move up by 9 units. You can choose to move the graph down by 9 units, but you know it's usually easier to just move it up by 9 units. So this x, this becomes y equals to x squared minus 9. Okay. So now that I've drawn this graph, then how to solve? How to solve?
The solutions, the x-intercept.
Why are the... So Darius said something very interesting. He said that the solutions are the x-intercepts. Why? Why will the solutions be the x-intercept?
Y equals 0.
Huh? Y equals to 0? Why is it that y equals 0?
That's the x-intercept.
I know that y equals 0 is for the x-axis. But why are we using y equals to 0?
Because I'm finding x.
Yeah, we are finding x, but there are so many x values over here. Why are you so certain that these two will be the solutions to the equation? Because the right hand side says y equals to 0. And that is the reason why. Okay? So we have already drawn this and we say y equals to, so we write out draw equals to 0. So I draw y equals to 0, therefore these will be my two solutions. Better sums, what are the two values? Negative 3 and 3. Yes, this is one way to do it. But I wasn't expecting you all to tell me to draw y equals to x squared minus 9. Instead, I was expecting you guys to say, draw the graph of y equals to x squared. Okay, this is what I'm expecting. So this is the graph of y equals to x squared. Then, this graph is insufficient for me to solve the question. What else do I need to do?
Draw a line.
What other graph should I draw? Y equals to 9. Why? Okay, so now I've got y equal to x squared. Let's talk about step 1. Step 1 is simply copy it down. Step 2, rearrange this left-hand side to make it like what I already have. Therefore, x squared minus 9 plus 9 equals to 9, right? Because the minus 9 plus 9 will become 0. So now my left-hand side looks like the graph I have. Last step is to write down, this is y equals to, and we write down the word draw. So y equals to 9. Draw this graph over here. This is y equals to 9. And the two intersection points will be the solution. What would they be? Left one, what is it? Negative 3. Right side? 3. How many solutions? 2. That's it. Then now we move on to the last type. It is no longer our usual algebra questions. So to solve graphically, what graph would you like to draw?
Basic angle one.
Okay, hang on. Yes? Below the? Do you mean this x-axis? No need erase, huh? This is the graph of y equals to 9. The previous graph. Okay, early on the graph that we drew was this one. This is 3. This is negative 3. This was y equals to x squared minus 9. So there are different graphs, or there are different parabolas. Okay? Okay, now back to question 3. And this is really important. I need all of you to discover something with me. What graph should I be drawing for the third one? First graph, what do you want to draw? Draw y equals to sine x. All can draw sine x? So x and y, what is the period? 360. So one cycle in 360, right? So our sine x looks like this. This is 360 degrees. Is this a okay, what is the amplitude? 1. So this side must be negative 1. Is this a complete sine graph? Okay, I label y equals to sine x. Is this complete now? Okay, this one is not too important. Amplitude done already. Okay, is this complete now? Is this complete? No, then what else do I need to do? Not yet, not the y got half yet. Label the what? Okay. 180, 90, 270. Okay, is this complete now? Yes. Okay, Darius, why not? Any more? Any more? Is this complete now? No. Other side? You mean this side? Do you agree with him? Yes. Now is it complete? If I draw the dotted line, all your minus 90, minus 180, minus 270, minus 360. Is it complete now? Then what else? Extend all the way. Literally you extend all the way. Hey, that's how the sine graph works, right? It goes on forever and ever. Okay? We talked about this before. Our sine graph goes on forever and ever, cosine forever and ever, tangent forever and ever. Okay, it repeats itself. That is why we call this the period, 360 degrees. It repeats every 360 degrees. Yes?
Normally the question will give us the range, right?
Yes, the question will give you a range, but there's something else I want you to realize over here. Now that we have drawn y equals to sine x, and assuming I've drawn everything already, what is the next graph I draw? Y equals to half. Very good. So I draw the graph of, this must be half over here, right? Y equals to half. Y equals to half. Now it's the time to zoom in. How many solutions are there? How many solutions are there for the graph for sine x equals to half? 1, 2, 3, 4. Yes? Or infinite? I hope you can see that it is infinite because it goes on and on forever, right? It's going to keep cutting and cutting and cutting and cutting. So there are so many solutions. But what is the solution that your calculator will give you? Okay, class, listen. Within this range, negative 360 degrees to 360 degrees. Within this range, how many solutions are there? 4. We can see clearly there are 4 intersection points. If you use your calculator, you do your sine inverse half, your calculator gives you a number, right? So which answer is it? Which of this is your calculator giving you? This one, over here. Your calculator is programmed to give you this answer only. And it is up to you to find out what this answer is over here. Okay? Now, what do you think this value is going to be?
180 minus 30.
150. Okay, 180 minus 30. But how do you know it is 180 minus 30?
30 is the basic angle.
30 is the basic angle, yes. Your calculator gave you the 30. It was our basic angle. So why is this 150?
Oh yeah, then your first quadrant.
First quadrant, second quadrant. In the second quadrant, first and second quadrant, we have AS, right? All positive, second quadrant, sign positive. So our x can also fall in the second quadrant over here. And given that the basic angle is 30 degrees, our theta, our x value will now be 180 minus 30. I hope you are visualizing the triangle. So this is 2 answers only. Then what about this answer over here?
Minus 360 minus 360.
So because it is periodic motion, we talk about the easier one over here. Okay? The next time it cuts will be 30 plus 360. Get it? Then after that it cuts again. It will be 150 plus 360. Plus 360 plus 360. Every single answer you plus 360, on and on and on, you get all the answers. On this side, you minus 360 from this to this. Then from 150, you minus 360, you get 210. Okay? The next part of the lesson, 8.8, will teach you how to do it systematically to find all the answers that are required in a given range. Because the question cannot tell you to solve for all the x. I will tell you, solve from 0 to 360 degrees, what are the answers? Solve from negative 360 to 360, what are the answers? And we won't be so bad to make you solve